So the goal here is to find the sum. What you want to do is figure out what kind of series it is and then find out which formulas you need. You take the first term, which is this, the 3, and then you also identify the second term, which is the -1. And you want to keep the subtraction sign with the 1, so it's -1. And now, what you can do is figure out if it's arithmetic, where you find the difference between the two terms. The difference would be the second term minus the first term, and you'd have -1 minus 3. This would be -4. You want to see if this is a pattern, so we have A3 now. This is the 1/3. So that's the 1/3. You do the same thing, just that you'd be saying it's A3 minus A2. So you take the A3 and you subtract the -1 from it to find out what the difference is, if there is a common difference. This would be a +1. Then you get common denominators. This ends up being 4/3. These are different. They have to be the exact same. If they were the exact same, you could go further and check that A4 minus A3 gives you the same number, that there's a common difference. But there isn't. Because this happened, it's not arithmetic. Now, there's a clue that it's a geometric one, and that's the fact that the signs alternate term by term. This happens with the geometric ones, but not the arithmetic ones. See how it goes from positive to negative, then negative to positive, and then it just keeps alternating. That's the clue that it's geometric. You still identify the first term, which is the 3. And then you take the second term, which is the -1. And for the common ratio, to see if there is one, you would say it's the next term divided by the one right in front of it. So that would be the -1 divided by 3, which is just -1/3. Now you do the same thing. You go and check if it's the same pattern. A3 is the 1/3. So to check if there's a common ratio here, you'd say A3 divided by A2. And when we plug these in, A3 is the positive 1/3. A2 is the -1. This will just cause the sign to reverse, and it becomes -1/3. So far, these are the exact same. And you can go further and check with A4. A4 is -1/9. It's the 4th term. You do it the same way. You start with the one you're checking and divide it by the one in front of it. This is -1/9 divided by 1/3. You can either resolve it this way, or if you want, you can split it up and say that you have -1/9 divided by 1/3. If you do it this way, you keep the first one the same. So you'd say that this is -1/9. You change the division into multiplication, and you flip the fraction, the second fraction. This is 3/1. Then you multiply across. So it's -1 times 3 is 3. 9 times 1 is 9. And this reduces. You can divide the top by 3 and the bottom by 3, and it turns into -1/3. So we have the exact same one every time. That means there's definitely a common ratio here. Now the goal here was to find the sum, but we had to also figure out what kind we're dealing with. Now we know it's geometric. Only the geometric one has the common ratio, not the arithmetic. So because it's a geometric one, there are two kinds. We want to know if it's an infinite kind or a finite. They have different formulas. For both of them, you need to know what A1 is and R. If it was finite, you'd also have to know what N is. but we only need to know these two for the infinite one. Here we already know that this is 3. A1 is 3. And here we found out that r is negative 1/3 for all of these. So r is negative 1/3. Since it's an infinite series, you'd use this formula where you have a1 over 1 minus r. And you plug these in. We know that a1 is 3. Then we have 1 minus r, which is negative 1/3. You can write it like this, or you can put it in parentheses. Either way, you at least want to resolve the double negative. Here we have minus a negative number. Subtract the negative number, and we get positive 1/3. And now you can do this in different ways. You can, since we saw a keep change flip here, let's do this the other way. This is the more direct one-step method to resolving the double fraction. This is called a complex fraction because we have a big fraction and there's at least one smaller fraction somewhere in there. Here there's only the one smaller fraction. So to resolve this, you look at the denominator of that smaller fraction and you take that, which is the 3, you take that 3 and you multiply all 3 parts by it. When you multiply the fraction, it's basically on the top like that. So the point of this is that these 3's will cancel out. That's what we wanted to happen. So then on the top there's a 9. On the bottom left, the 3 times 1 will be 3. Here where we have the 1/3 times 3, that just becomes 1. The 1 is the only thing left there. So here we got the 3 and the 1. When you add the 3 and the 1, you get 4 in the denominator. And that would be the sum. So that's it for this question.